Okay, guys, we're going to learn today about solving quadratic equations by factoring. Okay, there's a couple other ways that we're going to learn the next few days about solving quadratic equations, but right now we're going to learn about solving it by factoring. So first, what does factoring mean exactly? So factoring, basically, if you look at this right here, 3 times 4 equals 12. Multiplying is taking the 3 and the 4 and multiplying them, getting the 12. If you go backwards and unmultiply, take the 12 and say, I could have gotten that with multiplying a 3 and a 4. Finding that 3 and the 4, that's called factoring. And the 3 and the 4 are each called a factor of the number 12. Okay, so when we talk about factoring, factor as a verb means finding the factors. Factor as a noun means these factors, these numbers that get multiplied together to give you the result. So factoring is basically unmultiplying. Okay, it's the inverse of multiplication. And one other definition, solving something means finding the value or values of the variable which make the equation true. So 2x plus 6, the solution to that would be x equals 3. So now let's talk about solving for quadratic equations. Okay. Before we factor, though, let's review multiplying for a second, because factoring is going backwards from multiplication. So let's talk about multiplication process and then talk about how we can go backwards and get this, because if we multiply two binomials together, we will get a quadratic. Okay, 2 binomials multiplying together gives us a quadratic. Okay, and we're going to want to factor the quadratic, which would mean what we're going to do is take this and go backwards and find that. So let's see what's going on here, multiplying, and then we'll figure out how we can do that process backwards. Okay, so really quick, we're multiplying binomials. We take the first term in the first binomial and multiply it by each of the terms in the second binomial. Remember, x times x is x squared, and x times 3 is 3x, and then we'll take the second term in the first binomial and multiply it by both of the terms in the second binomial. 5 times x is 5x, 5 times 3 is 15. Same thing over here, x times x times 6, negative 4 times x, negative 4 times 6. And then we'll add the like terms, which is the two terms in the middle here. 3x plus 5x equals 8x, 6x and negative 4x will equal 2x. Okay, so the pattern that you might notice, if you want, you can stop and pause the video for a second, look for a pattern in where is this 8 and 15 relating to this original expression. How does this 2 and this negative 24 relate to this original expression? So you can think about that for a minute if you'd like. Here is the pattern. So in your result, the middle or x term, we'll underline that, the middle or x term is always the constant terms from the original expression added together. So the constant terms, the 5 and the 3, the numbers by themselves. So 5 plus 3 is 8. Negative 4 plus 6 is 2. Okay, so you can see, if you look at it for a second, why that is, but it's always this plus this added together gives you this number right here. Works there and works there. Okay. So algebraically, writing that out, we have x plus a times x plus b. So for this one, a is 5, b is 3. And for this one, the negative 4 would be the a, and the 6 would be the b. So whatever numbers a and b are, added together, they'll give you this coefficient on the middle term on the result, and the multiplied will give you this constant term in the result written in standard form. Okay, that's the first thing you got to notice. So that's the pattern that always works when you're multiplying two binomials with leading coefficients of 1. If there was a 6 or something, that'd be more complicated. We'll talk about that in a minute. Okay. Number 2, it's very easy to tell when the factored form version, that's these ones up here, when the factored form version equals 0, okay? So let's say the x plus 5 times x plus 3 equals 0. When is that true? Well, if x is 5, actually, if x is negative 5, then we'll have 0 times negative 2 equals 0, which would be true, right? So when x is negative 5, that's true. Also, if x was negative 3, that would be true. So true when x equals negative 5 or x equals negative 3. So that was pretty easy to see. If x is negative 5, that will make this part 0, and 0 times whatever this part equals will make it 0. Okay? If x was 0, you'd have 5 times 3. That wouldn't be 0. If x was 1, you'd have 6 times 4. That wouldn't be 0. Negative 5 and negative 3 are the only numbers that will make that work. So stop and think about that for a second if you're getting confused. Why does it have to be negative 5 or negative 3 for this right here to be true? Okay. So from the factored form, you can look at it and say, this is what x has to be to make that work. But what if you have the standard form of the equation? What if you just look at this equation right here and someone asks you, when will that equal 0? Well, what number, when x is 0, no, that'd be 15 equals 0. That wouldn't work. What number will make this true? Well, that's pretty hard to tell unless you say, wait a second, x squared plus 8x plus 15 is really just x plus 5 times x plus 3. How do you know? Because we multiplied x plus 5 times x plus 3, and we got x squared plus 8x equal plus 15. You zoom out for a second so you can see those together. So this is the same thing as this. We found that up here. So this is just that equals 0. Well, that equals 0. when this equals 0, because they're the same thing. Okay? And, oh, I just found when that one equals 0, so when this one equals 0, this one equals 0, like I was just saying, and this is true when x equals -5 and x equals -3. Okay. Zoom in on that for a second so you can see it. Okay. Wait a second, did I just say that there are two solutions? X doesn't equal just one number, it could equal two different numbers? Absolutely. Absolutely. I'm gonna not mark it on here. So you gotta mark the box that matches the name absolutely. Okay. Stop, it's definition time, because what is a quadratic equation exactly? A quadratic equation is an equation that has an x squared term, an x term, and a constant term. And the second two terms could be 0. So the only one that it's really required is the x squared term. And it can't have any other weird stuff added in with it. So it'll be y equals a number times x squared plus a number times x plus a number. Okay, or it could say a number times x squared plus a number times x plus a number equals 0 would also be a quadratic equation. It has to have an equal sign to be an equation, otherwise it's an expression. Okay, and also anything that would become this if you multiplied it and simplified it is still a quadratic equation. So this right here is quadratic even though it's not multiplied out and put in standard form yet. Okay, but if it's a quadratic equation, you can write it to look like this. Okay, we got that. We're going to move on to the examples. We go through these pretty quick. So, first example. Oh, I'm showing you too much. Okay, so from what we did over on the last one, we saw those two numbers added together gives you this, multiplied together gives you that. So we want to find what two numbers added together will give us -2 and multiplied together will give us -8. Okay, so I put all the factors of -8 that I could think of over here. -1 times 8 or -2 times 4, etc. Which of those will add together to be -2? -1 plus 8 is 7, -2 plus 4 is 2, 1 plus -8 would be -7, 2 times -4, or 2 plus -4. So those two multiplied together gives you -2, but 2 plus -4 gives you -2, 2 times -4 gives you -8. Okay, so we found two numbers that add to -2 and multiply to 8. So that should be our answer right there. X plus 2 and x minus 4. 2 and -4 are A and B. And that's the exact same thing as x minus 4 times x plus 2. Either one's the same thing. Should we check that really fast? Yes, we should. X plus 2 times x minus 4, if you multiply it out, yes, we get that. So we did it right. Okay, next one. X squared minus x minus 30. That's minus 1x, right? So the two numbers that we're trying to think of will have to add to -1, and they'll have to multiply it to be -30. So I listed all the factors of -30, and the ones that will add together to -1 are right here. And when you're listing them, you can stop when you find the one that works. So you first start with thinking of all the possibilities for multiplying, and then find which two of those will add to the right number in the middle. So I found all the possibilities for the -30, and then I figured out which one will give me -1. And if I multiplied that out real quick, I'd get x squared plus 5x minus 6x minus 30, which would be x squared minus x minus 30. And it worked. That's just checking my answer. That's the answer. You could also write it x plus 5 times x minus 6. The order of these two binomials does not matter. Okay. 4 more examples here. Sorry, this video is going a little bit longer than I wanted it to. Okay. So this one, you might think if you just look at that, oh, it's got to be 5 and 5, because that adds to 10 and multiplies to -25. So you might put x plus 5 times x plus 5. But then you think, oh, wait, -25, one of them has to be negative. But then if you put one negative and one positive, the 10 won't work. So we'll list all the possibilities to get the -25. It turns out there's no way to get this to work, okay? If it was plus 25 here, we could say x plus 5 times x plus 5. If it was x minus 10, x minus 25, this would work. Sorry, let me adjust that. Okay, so nothing will work, so you just put no solution, okay? There are no numbers that will multiply to -25 and add to give you a 10. Okay, x squared minus 4, you might think, whoa, what's going on? So the middle term is 0. Okay, there's 0x there. So what numbers add to 0 and multiply to -4? Well, think of all the possibilities. I'm going to say, which two multiply to -4 but also add to 0? These, which are really the same thing. So we got x plus 2 times x minus 2. Or you could put the -2 first and the +2 second. Okay. So even if it's missing one of the terms, you still do the same thing. Whatever term's missing is 0. And find, well, what will add to 0 or multiply to 0. Okay, this example right here, what adds to -9 and multiplies to -8 to +18? Well, I thought these are the things that multiply to 18, but they've got to add to -9, not 9. 3 plus 6 is 9, but what if I did -3 times -6? That will multiply to a positive, but then it will add to a -9. So when this is positive and this is negative, you're going to want two negative numbers. Then they'll multiply to a positive, but they'll still add together to get you that negative. Okay, last one. Again, there's a 0x in there. And what will multiply to -5 and add to 0? A +5 and a -5. Yes, there are unfactorable quadratic equations like this one. You can still solve it, but we're not going to learn about that yet. We'll learn about that in a few days. So there are also ones with a leading coefficient that's not 1, and those get more complicated. You can still factor some of them, but it gets a lot trickier if you try to do it by factoring. So just wait until we learn more ways. Okay. Sorry this video is kind of long. I will try to keep the next one shorter for you guys. See ya in class.